Hello, everyone. I am Sochi Obanya, a technical program manager at Microsoft, and I work primarily on Secure Boot. Presenting with me today is.
Hi, I'm Jordan Gurdon. I'm a senior TPM here at Microsoft.
Today, we'll be discussing an important lifecycle moment for Secure Boot, which is the expiration of the 2011 trust anchors. We'll be highlighting some of the different pathways for customers to update their devices and ensure Secure Boot remains serviceable post 2026. First things first, let's set some context here. In this first section, we'll cover what Secure Boot is, what certificate expiration actually means in practice, and the impact it'll have on the device. So, Secure Boot is a UEFI security feature that establishes a chain of trust during boot. It ensures that only trusted software runs during the device's boot sequence. It does this by verifying the digital signature of the pre-boot software against a set of trusted digital certificates known as the certificate authorities, and these are stored in the device's firmware. Now, trust in Secure Boot is established through a platform hierarchy structure, and here's a simplified model on the right-hand side. So there's the platform key, which is used to sign updates to the KEC, and it determines ownership and management. Usually, this is an OEM-provided certificate, but Microsoft also has PK. The key exchange key signs updates to the allowed signature database, the DB, and the disallowed signature database, the DBX. Now, for the DB, this just contains trusted certificates and hashes of allowed images, while the DBX contains revoked certificates and mostly hashes of vulnerable or malicious applications. So, Secure Boot is expiring for the first time since it was established, which is 15 years now. And this expiration, Microsoft can no longer sign with the 2011 certificate. So, to maintain the security protections provided by Secure Boot, we establish new certificate authorities or trust anchors, and these are the 2023 certificates. Now, the 2023 certificates directly replace the older 2011 ones, with exception of the Microsoft UFCA 2011, whose scope has been split into two certificates. So we have the Microsoft UFCA 2023 for signing third-party bootloaders EFI applications, and then the Option ROM 2023 for signing just Option ROMs. So what happens if a device doesn't get the new certificates? So the good news is devices that haven't received the newer 2023 certs will continue to boot and operate normally, and standard Windows updates will continue to install. However, these devices will no longer be able to receive new security protections for the early boot process, including updates to Windows Boot Manager, Secure Boot databases, or mitigations for newly discovered boot level vulnerabilities. Next, we'll separate the resolution story for getting the updated certificates into two paths, which is the new devices and in-market devices. So for new devices, OEM are required to include the 2023 certs on all new devices by default. So most new devices have been shipping with the 2023 certificates included since 2024. Secure boot configurations may vary on devices, as OEMs may include support for third-party boot applications and option ROMs. And switching over now to the in-market story. So the first step is to prepare your environment. And here, while most devices will be updated through the automatic Windows-driven solutions, which we'll discuss in the coming sections, you can start by validating and preparing your environment to receive these updates, and you should start by conducting an inventory. Now, most devices manufactured since 2011 have Secure Boot enabled, but you should always verify that, as these updates are not applicable to devices with Secure Boot disabled. For IT admins managing the rollout within their environment, you can start by grouping devices based on similar firmware attributes such as OEM name, model, firmware version, etc. And this can be used to serve as a sample set to test the updates before broad deployment. Deploying the Secure Boot certificates to your fleet of devices requires that the device's firmware play a role in completing the update. And while Microsoft expects the most device firmware will perform as expected, careful testing is needed before the deployment of the new certificates. This also includes engaging OEMs early and applying any firmware updates first before the Secure Boot certificate updates. Now, if there are virtual machines within your environment, the good news is most new virtual machines have the certificate update, but for long running virtual machines, updates can be applied through Windows like any other device, as long as the virtualized firmware supports secure boot updates. Lastly, we recommend setting up device monitoring prior to deployment so you have a good sense of the state of your fleet in advance. We encourage you to practice safe deployment practices and start deployment in small rings before expanding as success accumulates. So we recommend monitoring the update rollout across your environment using either the Microsoft Intune's remediations console or the Windows System event log. For the Intune remediation, Microsoft provides a monitoring approach using Intune remediations that gives admin real device level visibility into secure boot certificate state. This solution collects raw registry data, secure boot event telemetry, and device context, and reports it centrally in Intune without making changes to the device. With this visibility, IT teams can see exactly which devices have been updated and which are incomplete, and which may require device manufacturer intervention. This turns the secure boot certificate transition from a blind rollout into a measurable, manageable operation, reducing security risk and avoiding last minute surprises as the 2026 deadline approaches. Intune provides centralized visibility across all Intune enrolled Windows devices, and the scripts are provided at aka.ms/get-secure-boot. This can be used to collect secure boot and certificate state, registry values, device metadata, secure boot event log telemetry, and the results are exportable to CSV for tracking, reporting, and escalation. And these scripts run silently in the background with no user impact. For the Windows event log, we have added many new secure boot events to monitor the rollout in the Windows system event log. There are the 1801 and 1808 as the main status event IDs. So for the 1801 event, this means the secure boot certs and or the boot manager has not been updated. The device still needs to be updated via one of the solution pathways we'll talk about in the next section. For the 1808 event ID, this means the device has been successfully updated with the required certificates and the boot manager and has been updated to the Windows UFCA signed version. For the 1795, this indicates the system firmware returned an error while attempting to apply a secure boot DB, DBX, or CAC update. And this requires that you contact the device manufacturer to determine whether a firmware update is required or available. For the 1808, this indicates the secure boot update was intentionally blocked due to a known firmware or hardware issue, and that could cause update failure or instability. This requires that the device vendor for a firmware update that resolves that identified known issues. For 1803, this indicates the device lacks a platform key signed Microsoft CAC and preventing the CAC update from proceeding. This requires that you contact the device manufacturer to update or confirm a proper PK signed CAC provisioning for the device model. So, with environment readiness and monitoring in mind, let's walk through the solution pathways for in market devices. There are two broad deployment pathways for in market devices. Some solutions are automatic, so they fall under the Windows driven rollout, while the rest, the admin managed alternatives, are available for IT and admins that plan to manage the rollout themselves and require a bit more control over the deployment process. So, the first solution in the Windows driven rollout category is the controlled feature rollout, CFR. Here, Microsoft has grouped Windows client devices into what we call buckets based on shared firmware and hardware attributes such as OEM name, OEM model, firmware manufacturer, baseboard version, etc. Within each bucket, we start rolling out to a small set of devices to validate the bucket before expanding gradually as confidence grows and successes accumulate. Once we've achieved enough confidence for a set of buckets, we include them in the next Windows monthly cumulative updates and deploy the certs broadly. So at this point, all devices with the same firmware and hardware attributes as with the bucket, will receive that Secure Boot certificate update through the LCU. The CFR solution requires that devices are sending telemetry to Microsoft and are running in support versions of Windows 11 or Windows 10 with extended security update support. So, as previously mentioned, for buckets where we've seen enough successful updates through the CFR solution, we include it in the next LCU. To do this, we include these buckets in what we refer to as a high confidence list. This list is used to deploy the certificates to all devices with matching firmware and hardware attributes as the buckets within this list. We also plan to make this list available to all customers by publishing it online as frequently as it is updated. So IT admins can download this list and use it to manage the rollout within their environment. This solution is enabled by default for all systems, but as it leverages the CFR path, most buckets within this list will be for client devices. IT admins can also choose to opt out of this assist. With that, I'll hand over to Jordan.
Thank you so much, Sochi. In this next section, I'm going to walk you through how to manage the Secure Boot updates in your environment. Our aspirations were to meet customers where they are, and so we have 4 different options to do that. On this slide, we're going to talk about the key Windows registry values that support deploying, managing, and monitoring the Secure Boot key updates. These registry keys underpin all of our deployment mechanisms that we'll introduce later in the talk. Think of the registry keys as the control and visibility layer. Some of the keys are used to drive update behavior, and others are used to confirm status and troubleshoot outcomes. The first key is the available updates. This is the main control lever. This determines which Secure Boot updates the device should execute. When the right bit field is set, it will initiate the new certificate updates and the CA 2023 signed boot mugger. aka.ms/get-secureboot has more info on which bits control which updates. The second key is the Microsoft Update Managed opt-in. This key enables an organization to opt in to the controlled feature rollout feature that Sochi just explained. This is also referred to as Microsoft Managed. This will allow you to receive and apply the certificate updates more quickly than the high confidence list that ships as part of the latest cumulative updates, or the LCU. The last key is the high confidence opt-out. This is designed for organizations that want to opt out of the high confidence groups that would otherwise be applied automatically as part of the LCU. When Microsoft has confidence in a servicing update's quality and compatibility, the code is added to the LCU and serviced to our customers. The high confidence list is no different. When Microsoft has confidence in a device's ability to apply the certificates, we add the device to the high confidence list. The opt-out, while supported, is not recommended unless you have more granular control of updating on a device-by-device basis requirements. While Microsoft provides many solutions to support managing the updates, this process will be operationally expensive for most organizations. Next, let's look at the status keys. The UFCA 2023 status key reflects where the device is in the Secure Boot key update process, essentially the current state. The options are not started, in progress, or updated. The UFCA 2023 error key is your primary success failure signal. It stays at 0 when everything is successful. If anything goes wrong, it records a non-zero error for the first error encountered. The second management plane is in Microsoft Intune. We have integrated with Intune to provide a Secure Boot management experience for Intune managed client systems. In Intune, you can set the following settings to configure the registry key values we just talked about. The first setting is Configure Microsoft Update Managed Opt-in. This essentially sets the Microsoft Update Managed Opt-in registry key to opt into the CFR experience to get the certificates earlier than the LCU. Opting into the CFR experience requires diagnostic data to not be blocked by clients. The second setting is the Enable Secure Boot Certificates Update. This will set the available updates registry bitmask to immediately apply the certificate updates and tell Windows to boot with the new signed boot mugger. The last option, which again we don't recommend, is Configure High Confidence Opt-out. This again is opting out of the list we have developed when we have high confidence in a device's ability to apply the certificates. Let's take a look at the Intune management experience in more depth. In the Intune Admin Center, we're going to navigate to Windows Devices, Configuration, to create a new policy. We're going to set the platform type to Windows 10 and later, and the profile type to be settings catalog. We'll give the profile a name, and optionally, we can give it a description. Using the settings picker, we'll search for Secure Boot and enable the following two settings. Enable Secure Boot certificate updates, which will again start the deployment of the certificates once deployed to machines by setting the available updates registry key. We can optionally set the Configure Microsoft Update Managed opt-in, which will opt a device into the controlled feature rollout. Lastly, we use Intune to select the scope of devices to target. In this example, we're going to target all Intune managed devices, and we can refresh to monitor the progress of the policy update. We have also configured the management through Group Policy Objects, which is an enterprise-friendly mechanism for organizations that manage Windows devices through Active Directory. GPOs give IT admins explicit control over when, how, and through which channel Secure Boot updates and the CA 2023 side boot manager will be deployed. This feature impacts firmware of the computer, not just the user, so all settings live under Computer Configuration, Administrative Templates, Windows Components, Secure Boot. The first policy is the master switch. When this is enabled, Windows begins the certificate deployment process. This includes deploying the new certificates and the CA 2023 signed boot mugger. If it is not configured or disabled, Windows will not do anything automatically. The second setting controls Secure Boot certificates being delivered automatically through monthly servicing. This group policy setting name and experience is a little bit confusing on first read, so bear with me. Think of enabling as exiting the experience. So keeping the setting not configured or disabled means deployments occur by default. Again, our recommendation is to not enable or exit out of automatic deployment. The third option is about speed. This is the certificate deployment via controlled feature rollout. Again, this will opt you into the CFR experience if you want to receive the certificate updates more quickly than the LCU. The key takeaway is that GPO gives enterprises deliberate, audible control over Secure Boot certificate deployment. Again, you can choose when deployments start, whether servicing delivers it automatically, and how early you want to receive these updates. In this section, we're going to introduce the Windows Configuration System, or WinCS. These are APIs that Microsoft has provided to support querying and applying Secure Boot configuration directly onto Windows devices. These are best suited for organizations or individuals who want to manage the updates and to configure or customize the experience repeatedly via scripting. WinCS gives IT admins a repeatable, scriptable mechanism to both understand the current Secure Boot posture and enable the configuration. WinCS includes a command line interface, CLI, that runs locally on the system. There are two actions that matter the most. First, query the device's current Secure Boot configuration state. And second, apply the configuration changes needed to enable Secure Boot content. Microsoft's guidance is that IT admin should query first to confirm that device is in the right state and eligible for the updates, and then to apply the correct feature configuration to move the device forward into Secure Boot servicing progress. You can start by querying the feature or WinCS key. There's a separate key for disabled, which ends in 001, and another key for enabled, which ends in 002. Enabling this feature is effectively the green light that allows the device to install the new Microsoft-provided Secure Boot certificates, including the updated KEC, UFI-CA 2023 certificates. It will also update the boot mugger to the CA 2023 signed version. To summarize, WinCS is a supported control plane for Secure Boot configuration on Windows. The operational pattern is query first, then apply the feature key to move the devices into a secured state. Let's take a look at how to do this in practice. To get started with WinCS, we're going to first install and import my favorite UFI Secure Boot module, UFI v2, using the install module and import module commands. This is easily going to show us whether the certificates have been successfully updated. Next, we can run the wincsflags.exe and query for the Secure Boot enabled key. We can see that the current configuration is disabled as evidenced by the state and the key is ending in 001. Next, we're simply going to use the apply flag with the enabled key as an input. We can see that the current configuration is returned. For posterity, we can query the key again to check the current configuration. The last step before update is to manually run the scheduled task or to wait for its next scheduled run and reboot the system. To verify that the updates were successful, we use the UFV2 module to dump the certificates in the KEK and DB in human readable form. We can see that the 2023 certificates are in both. Optionally, we can use the inbox PowerShell commands documented at ak.ms/getSecureBoot to check the new certificates in the KEK and DB again. Here we can see that the commands return true, indicating that both certificates are in the KEK and DB. We have also improved on the inbox commands as part of the February 2026 non-security preview updates. Here, when specifying the decoded flag, you'll see the certificate contents of DB and KEK are presented in human readable form as well. This method can also be used to inspect other variables like DBX and the default values. That brings us to the end of our presentation. To recap on two frequently asked questions, will Windows Update deliver the new certificates automatically? The answer is yes. For most cases, Windows Update will deliver the certificates automatically to devices running in support Windows versions. Updates will follow two rollout channels. The first, Controlled Feature Rollout, CFR. This gives devices faster yet controlled rollout mechanisms powered by Windows Update. This explicitly requires an opt-in from IT admins and required diagnostic data. The second is the monthly latest cumulative updates, or LCUs. These are updated monthly with the high confidence list. As Sochi touched on, devices that don't update before the old certificates expire will continue to boot. However, devices will not receive future updates to Secure Boot and possibly the Windows Boot Manager. ak.ms/getSecureBoot is the one-stop shop for all questions related to Secure Boot updates, monitoring, and deployment methods. I demonstrated 4 methods today to deploy certificates and bootmugger updates, to opt into the Microsoft Managed Control Feature Rollout, or CFR, for quicker updates, and to opt out of the high confidence inbox list should you wish to manage it yourselves. ak.ms/getSecureBoot also provides a more detailed breakdown of each of those 4 methods, manually setting the registry keys, using Microsoft Intune, using GPO, and using WinCS to script the configuration. We also have a GitHub repository containing our Secure Boot objects with more information on the KEK, DB, and DBX updates. Once again, we want to thank you for tuning in to our presentation on Secure Boot updates. I am Jordan Girton.
And I am Sochi Omanya. Bye.